Hello everybody and welcome to Outcome 30.7c, which is all about, in this lesson and outcome, sinusoidal functions. So in 7a we did polynomials, 7b we did logs and exponents, in 7c we are now on something called sinusoidals. So in this lesson we are going to start by looking at characteristics of sinusoidal functions based on their graphs. Remembering that this piece ends up helping us out for the level 2 skills, in which we are going to match, just like we did in the previous two outcomes. So again, lesson 1, we are going to identify characteristics of the graphs of sinusoidal functions. So the first question you probably have is, what is a sinusoidal function? So before we get there, let's look at what we call periodic functions. So periodic functions are just functions that repeat themselves over and over and over and over again. So there's 4 graphs on this page, and every single one of them is periodic. You can see this first one repeats that pattern over and over and over again. Right, even the second one repeats this triangle line, right, repeats over and over and over and over again. The special one, though, is a sinusoidal function. So sinusoidal functions are periodic, that have the shape of a sine graph. So that's why they're called sinusoidal. What you'll notice is this right here is your sinusoidal. It repeats the curves, right? It curves down, curves up, curves down, curves up, over and over and over again. Things to note is that the peaks are always at the same height. The low spots are always at the same height. And the length of those curves, right, they're all the same. They don't get bigger or smaller. They're all perfectly the same as they move through. So again, all we're going to do is focus on sinusoidal functions. So when we look at sinusoidal functions, there's several different characteristics, which relates to different definitions that we need to learn. So the first one is period. A period is basically the length of the domain from one cycle. And when we say domain, remember that's on the x-axis. So how big is one cycle? So on here, they've drawn one complete cycle. If I start here and I hump up and then down, at this point right here, it starts to repeat the same pattern again. So that's one period long. I could also choose to start here. If I start there, the pattern would start to repeat itself right there. So this would be one cycle. You can choose to start and stop wherever you want, as long as it's only one full cycle. I can start down here. If I start on the bottom, I would curve up. When I get back down to the bottom, I would be done. There's another cycle, another period. So period is just how big or how long that cycle is. Next definition is midline. Midline is exactly like it sounds. It's a horizontal line that's halfway between the max, the high point, and min, the low point. So a way to calculate the midline is simply to take the max, add the min, and divide by 2. And you will always find your midline. Our next definition is amplitude. Amplitude is the distance from the midline to either the max or the min. No matter which way you go, you always say amplitude as a positive number. So here's the picture, right, where they have a midline. So if you look, the distance up to the maximum is 2. The distance from the midline down to the minimum is 2. So your amplitude would be 2. I would never say the amplitude is -2. It's always positive. Next thing you need to know is that when I say a sinusoidal function, it's either sine or cosine. The statement reads that the graphs of sine and cosine are congruent, which means they simply look the same. Really, if you look, the red graphs are sine and the blue curves are cosine. They look very much the same. It's simply like I picked up one graph and moved it left or right, and I got the second graph. So all graphs are both sine and cosine at the same time. And as you move forward in the unit, I will show you how you decide whether you want to call it a sine or whether you want to call it a cosine. And here it is. Okay? So the first two graphs are sine functions based on where they start. Right? When we call them sine functions, that's because they want to start at the midline. So if you look at those two graphs, look at this one. It's starting on the midline. Look at this one. It's starting on the midline. Where you start on the midline, you call it a sine. The second two graphs are cosines. Cosines start at the maximum. So if I look at these two graphs, look at this graph, starting up at a maximum. Look at this graph, it starts up at a maximum. So when it starts at a max, it is a cosine. The last little thing that I need to talk to you guys about is a radian. So there's a lot of stuff here about what a radian is. What I need you to know is basically a radian is just another way to measure angles. Okay? So we can measure angles in degrees. We can also measure them in something called a radian. There's also gradients, and there's minutes and seconds, but we're not going to focus on those. We're going to look at two ways, degrees and radians. So basically, you can tell the difference based on how they're presented. So for example, 10 with a little symbol there versus just a 10. When there's a symbol there, that tells you this is a degree. It's 10 degrees. When there is no symbols, that is a radian. So that would be 10 radians. So you're looking for that degree symbol. When the degree symbol is there, it's a degree. When it's not there, it's a radian. The other thing that's important to note is what is equivalent. So basically what you want to remember is 2 pi radians is 360 degrees. So basically, if you were to draw a full circle, right, that would be 360 degrees, something we're familiar with. In radians, we call that 2 pi. There's 2 pi's in a circle. And similarly, if I just draw half a circle, that's 180 degrees, which is the same thing as then half of 2 pi is just a pi. So that's just how they're equivalent. So when we say a full circle is 360, or a full circle is 2 pi. Again, just different ways to measure angles. So I've gone through a whole bunch of stuff. Now we're just going to do a couple examples to kind of let it all sink in. So it says we have 2 sinusoidal functions below. We are going to figure out the range, the midline, the amplitude, and the period. Well, first, I just want to talk about what we just did, radians versus degrees. When you see this, there's no degree symbols here. This is a radian graph. It's in radians. This graph, you see the degree symbol? This is a degree question. So that's what I need you to realize, right? Degrees have a degree symbol, radians don't. So now let's just go through the different characteristics it wants. First thing it wants is range. If you remember from the last unit, range is bottom to top. Bottom of this graph is at -4. Top of this graph is at 2. It does touch -4, so square bracket. It does touch 2, so square bracket. Next one is midline. So to find the midline, you take both numbers, -4, and you add it to the other one, 2, and you always divide by 2. So this is -2 divided by 2, so -1. The midline is y equals -1. It's really important that you write the y equals because it's a line. So here is my line. I typically draw it in dashed. You don't have to, but there's my midline at -1. From that midline is how I find my amplitude. I go from the midline, either up or down, to the max or min, whatever I choose. I typically choose to go up. So if I start on the midline here, and I go up to that maximum, I have moved up 1, 2, 3. My amplitude is 3. And the last thing I want is a period. Period is generally the hardest thing that students have to find. At least they feel like it's the hardest. So you need to find a start and then an end. So I'm going to start right here at the beginning of the graph. It's starting on the midline, so I would call this a sine graph because it is starting on the midline. Now a full cycle would come up, go down, and then come back up to the midline where I started. But I don't know where that dot is. So if I look at this, I see the first hump starting and ending there. That is half my period. So that amount is 2.5, right? I'm going from 0 to 2.5. If I double that, I get the full period of 5. So there's all the characteristics. We're now going to do the exact same thing for this example. So the first thing is the range, bottom to top. Bottom is -3, top is 7. Midline, I add those two numbers up and divide by 2. So y equals 2. Amplitude goes from the midline. So if I go from the midline up, I'm at 2. I go all the way up there. So 2, 3, 4, 5, 6, 7. I moved up. My amplitude is 5. Now the period. I pick a place to start and I pick a place to end. So let's say I start here. So if I start there, the way that I would end is at the next low point, right there. So in terms of tick marks, there's 3 tick marks for my period. But I know that each of those tick marks are worth something. Every 2 tick marks is 120. So 120 divided by 2 is 60. So this is really 3 times 60. So 180 degrees is my period. So that's just finding all of those different characteristics with a graph that's given to you. A nice place to start learning all of those definitions. I have one more example. It says, sketch a possible graph of a sinusoidal function with the following set of characteristics. I want to graph it over a domain between 0 and 180. So that basically just means I'm going between 0 and 180. So when I make my grid, I start at 0, I'm going to end at 180. I'm just going to put a few more tick marks in. Halfway would be 90. Halfway would be 45, which means this middle piece would be 90 plus 45, so 135. Good enough. My range I want to be between 2 and 6. So my entire graph is going to go between 1, there's 2, 3, 4, 5, and 6. So it goes between 2 and 6. So 2 plus 6 divided by 2, and 8 divided by 2 is 4. My midline will be at y equals 4. So I'm going to quickly just draw that in. There's my midline. I know my period is 90, so that means I need to make an up, down, and 90, which means I can make another up, down, for another 90, and 90 plus 90 is 180, so I'm going to make 2 cycles in my graph, and I know that my y-intercept is 4, so it's going to start here. So it's a sine graph because I'm on the midline. So I need to make one full up-down between 0 and 90. There's the 90. So I need, this is my halfway point. I need to hump up. I need to hump down. Oops, I didn't go down enough. I didn't get down to 2. So same thing, I need to do another one. I can start at 90, go to 180. My halfway point is 35. I need to hump up to hit 6. I need to hump down to hit 2. And there's a sketch of a sinusoidal graph with that characteristics. Again, it's a sketch, so it's not going to be perfect. It's one option that there could be. So now at this point, here is the page of all of a summary of the things we just talked about. It's your turn to try some on practice 1.